The next topic is about backtracking. Backtracking is an algorithmic technique for solving a problem by an incremental way. So it uses the recursive approach for solving the problems. By using the backtracking, we can find all possible combinations to solve an optimization problem. From the name itself, you come to know that we can backtrack to find out the solution. So we start with one possible move out of many available moves and try to solve the problem. So this is called as backtracking. So the backtracking problem requires that all the solutions should satisfy some set of constraints. The two types of constraints are explicit constraint and then implicit constraint. So this explicit constraint refers the rules which are restricting each xi to take values from a given set. It depends on the particular instance of the problem which is being solved. For example, xi greater than or is equal to 0 or si is equal to all the negative real numbers. So this is the explicit constraint, and the implicit constraint is the set of rules which determines which of the tuples in the solution space of I satisfy the criterion function. So the general steps of backtracking are: start with the sub-solution and check whether the sub-solution will lead to the solution or not. If it does not lead to the solution, then come back and change the sub-solution and continue again. So these are all the general steps of backtracking. So the example for the backtracking or Sudoku solving, n queens problem, sum of subset problem, and then graph coloring problem. So with the help of the backtracking, Sudoku solution will be found out and n queens problem will be solved with the help of backtracking. Sum of subset problem as well as graph coloring problem will be solved with the help of the backtracking technique. So let's see the first problem, which is called as n-queens problem. So the n-queen problem will be used for solving the it will be used for the chessboard. So the n queen is the problem of placing n chess queens on an n by n cross n chessboard so that no two queens attack each other. So for example, suppose the chessboard is having 8 cross 8 squares, then no queen should be placed which will attack each other. So that we have to place all the n queens in such a way that no two queen is in the same row, no two queen should be in the same column, as well as it should not be in the same diagonal position. So how to solve this with the help of the n queens problem? Let's see. So the first figure represents a queen problem. So here all the queens are placed in each row as well as in each column, whereas it satisfies all the three conditions. That is, all the queens are not placed in the same row, they are not placed in the same column, as well as they are not placed in the diagonal position. So in this example, the first queen is placed at the position 0, 0, that is 0th row and 0th column. The second queen is placed with the second row as well as the 6th column. The third queen is placed with the third row as well as 4th column. The fourth queen is placed with the 4th row and then 7th column. The fifth queen is placed with the 5th row as well as with the first column, and so on. So the second diagram represents four queen problem, whereas here also the all the four queens should not be placed with the same row, they should not be placed with the same column, and they should not be kept with the diagonal position. So let's see how the four queen problem is solved with the help of the algorithm. So here in four queen problem, it contains four queens on a 4x4 chessboard, so that no two queens can capture each other, otherwise they should not attack each other. So let's see about the four queen problem. In four queen problem, it contains four queens on a 4 by 4 chessboard so that no two queens should attack each other. That is, no two queens are allowed to be placed on the same row. They should not be placed on the same column. Otherwise, they should not be placed on the same diagonal. So the algorithm is in queens, the parameters are board, comma, column. So begin, if all the columns are filled, then return true. For each row of the board, do if is valid board comma I comma column, then set queen and place I comma column in the board. If solve when queen of board comma column plus 1 is equal to true, then return true. Otherwise, remove queen from place of I comma column from the board. Otherwise, return false end. So this is the algorithm. So according to this algorithm, first it checks whether all the columns are filled. So if all the columns are filled, then it will return true. Suppose some of the columns are not filled, then it will enter into the for loop and it will check each row. Okay, so for each row, the for loop will be executed. If it is valid board as well as the I as well as the column. If the board value of the board, if the value of the I, if the value of column all are valid, then it will enter into the true part. Then it will set the queen at the place of the ith position as well as the specified column of the board. Suppose the I value is 1 and the column value is 3. Then ith row as well as that is first row and third column, the particular queen will be placed. And it will check one more if condition. If solve n queen, board comma column plus 1 is equal to true, then return true. So it will check the next column. If the condition is satisfied, then it will return true. Otherwise, it will remove the queen. That is, it checks whether the queen is placed on the same row, or if it is placed on the same column, or if it is placed on the diagonal. If it is like that, then it will remove the queen from that particular column from the board. So this is how the algorithm works. So the explanation is given here. So we start with the empty board and then place the queen 1 in the first possible position of its row, which is column 1 of row 1. Then we place queen 2 after trying unsuccessfully columns 1 and 2 in the first acceptable position for it, which is square of 2 comma 3. That is the square in second row as well as the third column. It shows that it is the dead end because there is no acceptable position for the queen 3. So the algorithm backtracks and then put queen 2 in the next possible position, which is the second row as well as the fourth column. Then queen 3 is placed at the position third row and second column, which proves to be another dead end. So again the algorithm backtracks all the way to queen 1 and moves it to the first column, first row and second column. Queen 2 now goes to the second row and fourth column. Queen 3 will move to third row and first column, and then queen 4 will be moved to the fourth row and third column. So this is the final solution. So the diagram is also given. So the first queen is placed on the first row third column. The second queen, this is the final result after backtracking in order to set the condition, that is all the queens will not be at the same row, same column, as well as they should not be at the diagonal position. So when the condition matches like this, the algorithm backtracks and it sets the queens like this. So this diagram represents the final solution of the four queen problem. According to this algorithm, the first queen is placed with the first row and third column. The second queen is placed with the second row and first column. The third queen is placed with the third row and fourth column. Finally, the fourth queen is placed at the fourth row and second column. So this is what the four queen problem works. And so, as I told you earlier, backtracking is nothing but when the algorithm is finding out the solution, and if the solution is not reached, then from the current position, once again the algorithm will go back to the previous position and it will start from the scratch. So this is called as the backtracking. And we discussed how the four queen problem is solved with the help of the backtracking. So the second example shows sum of subset problem. So sum of subset problem will also be solved with the help of the backtracking method. So before knowing how the sum of subset problem is solved with the help of the backtracking technique, you have to understand about the sum of subset problem. So what is sum of subset problem means? Consider the subset which is given in this example, that is W is equal to 1, 3, 4, 5. That is, this is the given subset. So M is equal to 8. This is also given. So the possible subsets of W, you have to take the possible subset from W whose summation will lead to 8. So you have to take the summation like this. You have to take the subset like this. With the help of those subset, the addition of the values from the subset should be 8. According to that, you have to create the subset. So in the given example, the set is W is the set which includes the values 1, 3, 4, 5. Suppose the addition of the subset values should reach 8. So according to that, you have to select the subset. Suppose you are taking the value 1, 3 and 4 as the subset. So add these three values. 1 plus 3 is 4, 4 plus 4 is 8. So you can consider this as the subset because the summation of the values of the subset will be equal to 8. So 1, comma 3, comma 4 is the valid subset. Suppose you are taking 1, comma 4, comma 5 as the subset. So what is 1 plus 4, which is 5. 5 plus 5 is 8, which is not equal to, 1 plus 4 is 5, 5 plus 5 is 10, which is not equal to 8. So you cannot take 1, comma 4, comma 5 as the subset. So from the given set, you have to take only the subset whose summation will be equal to the given value, which is 8 in this example. So consider one more subset 3, comma 4, comma 5. 3 plus 4 is 7, 7 plus 5 is 12, which is not equal to 8. So you should not consider the subset 3, comma 4, comma 5. So you consider one more subset 3, comma 5, whose summation is equal to 8. So the valid subsets are 1, comma 3, comma 4 as well as 3, comma 5. These two are the valid subsets whose So this is called as sum of subset problem. That is, the sum of subset problem can be given as, suppose we are given n distinct positive numbers and we desire to find all combinations of these numbers whose sums will be equivalent to the given number m. So as I told you, with this example, the given set is W is equal to 1, comma 3, comma 4, comma 5, and the given m value is 8. So you have to form the subset from the given set whose summation will be equal to the given m value, which is 8. So, so the valid subsets are 1, comma 3, comma 4. That is the first subset, and the one more subset is 3, comma 5. So this is the algorithm. The first step is, first you have to start with an empty set and add to the subset the next element from the list. If the subset is having some m, then start with that subset as the solution. If the subset is not feasible, or if we have reached the end of the set, then backtrack through the subset until we find the most suitable value. And if the subset is feasible, then repeat from step 2. If you have visited all the elements without finding a suitable subset, and if no backtracking is possible, then stop without solution. So these are all the steps of the algorithm. That is, first we have to begin with the empty set. Then we need to form the subset which satisfies the condition that the summation of all the subsets should be equivalent to the given number m. If the subset is not possible, then when we are reaching the end of the set, then once again we have to backtrack through the subset until we find the suitable value. Suppose the subset is feasible, then go to step 2 and repeat from the beginning. Suppose we are visiting all the elements without finding the suitable subset and no backtracking is possible, then stop without the solution. So these are all the steps to solve the summation of subset problem using the backtracking. So here the example is given. So M is equal to 30 and the set given set is W is equal to 5, 10, 12, 13, 15, 18. So these are all the values of the given set. So what is our constraint? We have to form the subset from the given set whose summation will be equivalent to the given M value, that is 30. So for example, just for example, I am saying you 5, 10, 12. Take the first three elements. 5, 10 is 15, 5 plus 10 is 15, 15 plus 12 is 27, which is not equal to 30. So you cannot form the subset like that. In the same way, you have to form the subset. So let's see how to form the subset. So initially, the subset will be empty and the summation value is initialized as 0. So this is the initial condition. So now you are taking the first value and included with the subset. So 5 will be the element which is in the subset. So you're adding the subset value with the summation value. So 5 plus 0 is 5. So 5 is added with the subset and then take the next value and include with the subset. So now the subset includes two values 5, 10. So add 5 and 10. So addition of 5 and 10 will be 15, which is less than the given value, M value, that is 30. 15 is lesser than 30. So add one more element, that is the third element. So 12 is the third element. So you are adding the third element also with the subset. So 5 plus 10 plus 12, which is equal to 27, which is also lesser than 30. So you need to add the next element, which is 13, 1, 3. So you are adding 13 also with the subset. So 5, 10, 12, 13. So when you are adding all the values, that is 5 plus 10 plus 12 plus 13, you are getting 40, which is greater than the specified M value. So sum exceeds 30, hence you have to backtrack. So from where you have to backtrack? 5, 10, 12, 13 you have to remove and backtrack from the third step. Okay, you have to backtrack from the third step. So 5, 10, 12. Why you have to backtrack from the third step? In the third step, the condition is satisfied. That is 27 is lesser than 30. So up to this, it is valid. From the fourth step only, the condition is not satisfied. So backtrack to the third step and add the next element. That is 15 is the next element. So you are adding 5, 10, 12, 15. So when you are adding all the elements, again you are getting 42, which is exceed than the M value, that is 30. So once again backtrack to the third step. So consider these subset values 5, 10, 12 and add the last value also. So when you are adding the last value, the subset becomes 5, 10, 12, 18. When you are adding all the values of the current subset, you will get the value 45, which is also greater than the given value 30. So once again backtrack to the third step. That is 5, once again backtrack to the second step. So 5, 12, 13. You consider these values whose summation gives the value of M, whose summation is equal to the given M value. That is 5 plus 12 is 17, 17 plus 13 is 30, whose value is equal to the given m value. So the obtained solution is, the subset is 5, 12, 13. So from the given set, the subset which satisfies the given condition is 5, 12, 13. So this is the final solution. So according to this, by forming the state space tree, the solution is find out. So this is the state space tree. So this state space tree represents how the solution will be backtracking to the previous solution. When the solution is not feasible, then once again it will backtrack to the previous step. So this is the way of solving the solving the sum of subset problem with the help of the backtracking technique. So the next problem is graph coloring problem. So what is graph coloring problem? This graph coloring problem can also be solved with the help of the backtracking method. So what is graph coloring problem? That is, first I'll show you the diagram and then I'll explain what is graph coloring problem. So here this is the given graph 1, 2, 3, 4. 4 vertices are there. So you need to assign the colors to each vertex in such a way that it has to satisfy the particular constraint that the same color will not be with the adjacent vertices. That is called as graph coloring problem. That is, for example, you have three colors, red, green, blue. So you have to set one particular color to the first vertex. For example, you are assigning red to the first vertex. What all the adjacent vertices of the vertex 1? 4, 2, and 3 are the adjacent vertices of 1. So 4, 2, and 3, all the three vertices should not have the same color red. So you have to assign some other colors for all the three vertices. Similarly, consider the vertex 2. The adjacent vertices of 2 are 1 and 3. Suppose you are assigning the value blue to the vertex 2, then 1 and 3 should not have the same blue color. Suppose consider the third vertex. If it is assigned with the color green, the adjacent vertices of 3 are 1, 4, 2. So all the three vertices should not have the same color. So this is called as graph coloring problem. So what I have explained is given in this particular paragraph. So given an undirected graph G of V comma E, where V refers the set of vertices and E refers the set of edges, and a number M, determine if the graph can be colored with almost M colors in such a way that no two adjacent vertices of the graph will be colored with the same color. This is the constraint of the graph coloring problem. So how the color can be assigned with the particular vertex? By satisfying the condition no two adjacent vertices should have the same color. By using the backtracking technique, the graph coloring problem will be solved. So let's see the algorithm for the M coloring, that is graph coloring problem. So this is the algorithm. So repeat next value of k. If x of k is equal to 0, then return. If k is equal to n, then write x of 1 is to n, else m coloring of k plus 1 until false. Until it became false, you have to repeat the steps. So here, uh, first, for the node 1, I have assigned color 1 for color 1, and for node 2, I have assigned color 2. For node 3, color 3. Node 4, color 2 is assigned. So so when you look at this, you can see node 1, color 1 is assigned. What are all the adjacent vertices of node 1? 2, 4, 3. So look at the second vertex, it is color 2 only. Third vertex, color 3 only. Node 4, color 2 only. So available colors are 3. So you when you are assigning color 1 to the node 1, the remaining adjacent vertices are not similar to color 1. They are having different colors like color 2, color 3 and then color 2. So when 2 and 4 are having the same color, so you have to look at the graph whether 2 and 4 are adjacent vertices. 2 and 4 are not adjacent, so they can have the same color. If the vertices are adjacent, then only they should not have the same color. So this is the way of solving the problem with the help of the backtracking. So where you can use this graph coloring problem, what are all the applications of the graph coloring problem? Let's see. So you can make use of the graph coloring problem for making a schedule or for making a timetable. And next one is mobile radio frequency assignment for set, that is for setting the radio frequency. We can make use of the graph coloring problem, as well as for coloring the map. You know about the geographical map of the particular country or for the particular state, where no two adjacent cities can have the same color. So for this graph coloring problem will be useful. So when you are coloring the map, then it is enough to have a 4 color for coloring the entire map. So the applications of graph coloring or making the schedule or timetable for setting the radio frequency assignment, as well as for coloring the map. That's all.